Hi everyone, I'm Matt. I'm a data engineer in the ML platform team, the machine learning platform team at Shopify. And I've been the main tech lead to implement a feature store at Shopify. So basically, I'm going to talk about that today, and feel free to reach out also on Slack afterwards.
I'm Mike Moran. I'm a principal engineer at Skyscanner. I've been at Skyscanner for quite a while now. It's coming up for 10 years. I've seen a few different changes, but the past 3 to 4 years has more been focusing on the kind of machine relevance and machine learning space, which I'll touch on in a minute.
Awesome, great. Thank you so much, guys. So to start off this session, Matt will start with a talk. Then we have a small Q&A for folks to feel free to shoot your questions. And then we pass to Mike, which will as well give us a talk about Feature Store as well. So Matt, please show us what you got there, please.
Yeah, sure. Let me share my screen first. So hi everyone. So I'm going to talk about what we did when we wanted to implement a feature store at Shopify. I basically want to cover 3 main things. Is the different aspect of choosing solutions. You can do in-house, open source. You can go with managed services. Then I want to explain why we went with Fist, that is an open source feature store, and how we implemented it at Shopify and what were some of the technical decisions in there. Very quickly, just to make sure we are all on the same page, Shopify is tech company to make commerce better for everyone. And so today we have millions of merchants using our platform, which means that they generate a huge amount of data every day. And so, for example, the first use case we wanted to onboard when we wanted to do a feature store, it was about 2 entities or 4 feature use, but that was not a huge use case because there's only 15 features from an ML perspective, but it was on billions of rows. So what was also very important to us was how would that scale on the offline side of it, for training or batch prediction, as well as on the online side of it, for online inference. So when we wanted to choose a solution, we basically had 3 different options. Either we go with a managed service that could be Google AI platform, Vertex AI, for example. We could also go with just a full in-house service. For example, we're thinking about doing it with Apache Flink, and then you just build everything yourself, all the logic. The good thing with Flink, for example, is it can process batch of data as well as streaming data. Or the other options open source, and for example, Fist is one of them. So very quickly, on the managed service, one of the problems you can have is to have this kind of locked-in vendor situation. So one of the issues that was for us is if we go with especially with the cloud providers, as soon as you want to change or you want to migrate, that will be a real pain to do migration for your users. Also, especially if you go with a big managed service, you're going to have issues to make changes in their roadmap. Even though Shopify is a big company, sometimes you need features that only going to come in 6 months, and then you're kind of blocked for months because of that. So managed services remain a good option if you have a limited team and you want to go fast and you don't want to do any infrastructure work, for example. Then we thought about in-house, and we explored that option a bit more. What you need is definitely a bigger team, because you need to do create the infrastructure, create the business logic, create a ton of things in-house. One of the main problems is you can drift from the standard practices of the ML community, and that's why a lot of tech companies today create in-house project, because they don't have choice, and then they make it open source, like Hadoop or Apache Iceberg now, that was from Netflix. So they really try to make their tools the standard of the community and to not drift too much from there. Another thing that I think is important with in-house solution when you do everything in-house is like you have a very limited scope of assumptions. And what is good when you are, like, for example, working with like open source project is like you are challenged for your assumptions and you try to build things a bit more, let's say, long term. So it remains good when you have very specific requirements or when you can make that open source at the end. And then the last one was open source. For us, there are other issues to take, other things to take into consideration. Like if the project is not maintained anymore, you can end up with some dead code. It can be slow to get RFCs or PRs approved. And it can also come with like a lot of unneeded features that you don't need or components you will need to support. That remains good option if you have a couple of engineers that can be involved in that open source community, and therefore they are willing to like make changes directly to the repo or contribute back to it. So on our side, we decided to go with Fist as our long-term solutions. What we were looking for when we explored those three different options, it was first to have like consistency between training and prediction, to have a unified API. So what our users want is like to get features for training and for batch prediction and for online inference kind of in a consistent manner. They should not change their code too much to do that. Another thing that is important at the scale of Shopify is to reuse feature cross project and across team. And therefore for us, reusability of that was pretty important. And the last one, because I told you quickly about the use case, is definitely scalability. So when we look at Fist, there was this diagram of what Fist is about. It's basically a library that tried to be plug and play with different store or different like systems. And then it will handle things like a registry, or it will give you like a unified API with an SDK. And so what was very appealing to us, it was like the offline and the online store can be, are not part of Fist. Fist is just a library that connects to those stores. So for example, at Shopify, we use BigQuery, but we also use Trino or Presto. That is also another distributed SQL engine. So we just created a community plugin of a Trino offline store, and we just made it available to the community. But that was very important to us because if this was really storing the data as a lot of feature store, it would mean that it would have to handle the scale of Shopify, which was not necessarily something that would be obvious. On the online store, for example, another thing that is, we have our own key value store. And therefore, what was important to us is to reuse this key value store instead of using Redis or DynamoDB or any other key value stores. And so it's the same. We created our own custom online store, and Fist is now able to read our custom online store. That is not open source. It's just private code, and this is fine with it. So we really like this plug and play ability of Fist. That we could not have with like a managed service, for example, or we could not have with other solutions. Another thing is like that was important for us is to have this unified API where you can fetch features for batch or for online inference in a pretty consistent way. I'm going to get back to that because we still created a thin layer between the Fist API and our users, and we have our own internal SDK for that. And I will explain the why of that too. So the why is Fist is, so this is how things are done in my mind. It's like Fist is like the open source solution. Then we have a Shopify internal library that is built on top of Fist. And we don't really hide that. Like we even sometimes tell our users to check the Fist documentation and we're fine with this. The thing is like our users are going to interact with our internal library only. So that first, if they're unblocked and we can unblock them, if they're blocked and we can unblock them with some quick hack, we're just going to make changes in the internal library and then report the issues back to the community and back to Fist through RFCs, GitHub PRs, GitHub issues. Another thing is like Fist, for example, comes with a lot of features and flexibilities that we don't necessarily want to own. And therefore, we have an abstraction layer that try to remove some of the flexibility of this, but at the same time make things much more easy to use for our users. And that's definitely, that was a technical decision for us, because you're like, if you abstract too much, what's the point of using this? But at the same time, if you don't abstract enough and then this make breaking changes in the future, everyone will need to migrate. So there's definitely trade-offs here in this abstraction of like, how do we make sure we can do most of the migration and support for our users while they have what they need, basically. And last but not least, it's like, as I was maybe saying at the beginning of the presentation, it's like when you contribute back to an open source software, you are challenged by for your assumptions. So for example, Twitter is using this today, and Robinhood is using this as well as Shopify. And last time, we had like very interesting conversation with the Twitter people, just because we didn't necessarily have the same point of view, which is fine, but it just makes your assumptions a bit bigger, or like the set of assumptions a bit bigger on your side. So internally, how did we really implement that? I think like for us, when we decided to go with this, there were two approaches. Either you go with like a multi-repo approach, so you tell our group of users to create a repo, and you have like a scaffold, you scaffold everything, and they, for example, interact with this directly. That was one option. Another one is like and that option is very appealing also to make your users owning the code and owning what they produce, so that if there is migration work to do, you are not the team responsible to it, your users are responsible to do it. Another approach is to do more like mono-repo, and that's the one we chose. Just because we wanted, like, one of the main reasons is because we wanted to try to get as many features reusable by as many teams. And if it's in the same repo, everyone can see what are the features available. I think at the end, it's also because FIS today does not have a web UI. They are working on that. But maybe if there was a web UI, we would have done things differently. But like today, there is one repo where all the features are defined, and everyone can, say, oh, there's something I should use instead of creating a new one. And on that note, for example, there's no good or bad answers. I think, if I'm not mistaken, the Twitter folks are doing a multi-repo approach. So it's not like, it's not one size fits all here. So how our repository is scaffold or is organized is like there's an entities folder, and an entity on this is just like a concept, like a user, a driver, a product, a customer. Then there's a features product, and those features, it's like, where do they come from? I talk about the offline stores, the online stores. So for example, the sales stat feature view. So this concept of a feature view come from some data, like batch data in BigQuery, and some data set in the key value store. So, and then there's like a feature service that is more user facing, where you say my fraud detection V1 is composed of 10 features coming from different entities, for example. And my V2 is composed of different, like of the same 10 features, but maybe with 2 extra. And therefore, it's very easy to just say, in your notebook, in your local environment, or in your production pipeline, to just say, give me my features for fraud detection V1, and then do some A/B testing outside, and then compare with fraud detection V2. So this is why we also like the mono-repo approach. It's because if someone wants to create an entity, they're going to go to this entities folder and say, hey, there's already a user or a driver or product entity. Maybe I should reuse that instead of creating a new one. And same for the features in general. As I told you, there's also this, there's also the SDK we built. And really the goal is to say, to plug all the Shopify logic in there. So for example, when you create a feature, we created a feature class, Python class that inherits from the first feature Python class, and we just enrich it. We just add like things that is very specific to Shopify. And we also add maybe validation about like naming or how things should be organized. Like we try to be opinionated here. The good thing with this mono approach concept is like, as soon as you merge a PR in this repo, all the continuous deployment is done for our users. So like updating the registry, creating data sets somewhere if there is a need for that, and making sure that those features are like available to all as soon as the PR is merged. And the other good thing with the SDK is like this, our own SDK, where there's the FIST APIs as well as like enrich. So with the Shopify logic, this SDK is used within the entire ecosystem of Shopify, which is like Jupyter notebooks, production jobs. It can be local environment, or even in our Ruby app, for example. So, for example, today we did not necessarily build a panel or like this mono-repo Ruby SDK, but we could definitely just build a small SDK in Ruby that is doing what we need to do in Ruby. And therefore, we kind of try to get the benefit from FIST, and we try to contribute as much as possible with FIST, as explained here, and with the maintainers. But at the same time, have the liberty to just like expand that and not wait on them to build what we need, but also just build what we need beforehand. Yeah, so I think I will just let people ask questions. Thanks for listening. Feel free to reach out on Slack or LinkedIn or whatever. And yeah, I'm happy to answer your questions.
Thank you, Matt. Great presentation. So who wants to go first?
I have a question, Matt.
Yep.
So regarding the scale of Shopify, I will assume it has a very large traffic and very sensitive latency requirements. Does this satisfy your need regarding the online inference? Because I saw the like FIST benchmark recently. It seems the performance has been improved. Just curious if that's an issue inside Shopify.
Yeah, that's a great question. I think for me in online inference, there are two components. There is like the latency when you ask for features, and FIST is not really in the picture because we have our own key value store, right? FIST is just a library that is going to ask our key value store to fetch the features for the user. So on that side, we don't use the FIST server, for example. We have our own like online store. So latency is not really a concern, or it's not really a FIST issue. And then when I think about online inference, I'm also thinking about like data freshness, where like how fresh is your data in your online store. And it's the same. This happens outside of FIST. So basically we have like batch and streaming pipeline that populate or put the data in the offline and online store with like custom code we give them, like custom loaders or sync. And then we just tell FIST, hey, the online data is here in our own key value store. The offline data is here with our BigQuery or own offline store. Just, do the glue, do the magic to our users, right? So in that case, latency and freshness is really controlled outside of FIST. It's not like FIST itself doing it. And that's what was appealing for Shopify, because FIST does not store the data. We don't rely on the FIST infrastructure or the FIST component on those critical questions.
I see, but I wonder, like you mentioned, like Shopify built its own in-house online store, right? Then does it still rely on FIST to like serialize the data serialize the data and write them into the online store?
No, it does not rely on FIST for that. We have our own. So basically, we have our own connectors, our own tools to move data from one storage to another. So from like offline storage to online storage, we have our own pipelines doing that automatically. So FIST is not really. That being said, what you said is important. It's like FIST is working on this, optimizing this online inference and try to serialize data in a certain way. So maybe at some point, it will even make more sense to use Fist and like a Redis cluster directly than to use our key value store. Maybe at some point, it will make even more sense for Shopify to do so. It's just like we did not start that way for now.
Okay, cool. Thanks.
No problem.
Matt, so the internal library is like kind of a subset of the Feast library. Is it like whatever the features needed for Shopify, you had taken as a copy and modified it for Shopify use, is it?
I think it's kind of the opposite. I think it's like Feast is a subset of the internal library. It's like the internal library as a dependency Fist as a requirement, right? And then we just like, you have access to the Fist APIs, like public APIs, but you have access to other APIs that we built on top of it because they make sense in the context of Shopify, right? So it's kind of more the opposite. Like Fist is a subset of the internal library, but the internal library is a thin layer for now. Like we don't try to reinvent everything. We try to just like, build the least amount of things, but still we still need to add logic or build things on top of that. Yeah.
Okay, got it. Thanks.
There's also a question from Victor. Did you guys consider when thinking about multi-repo approach using maybe Git submodules or subtrees to unify the features under a view repo? Yeah, yes, we considered a lot of approaches. And as I told you, there's no like good or bad answers on that one. I think we still preferred we had long conversation about that one. We still prefer to do like the mono-repo at the beginning to like control also how's data, how people created features and to make sure the features in the feature store was like met at a certain standard in terms of naming, in terms of like data quality. Like we wanted to make sure that was not a junk feature store or database. That being said, maybe, especially if Fist at some point build a web UI on top of it, that would be easy to have like the full, like to understand what are all the features available. Maybe at that time, we would decide then to just break that mono-repo and do like a different approach. And I think like I need to confirm, but I think David from Twitter, that is one of the main point of contact I have. I think they are doing multi-repository on their side where you do like you scaffold project for the users and you do things a bit different. So, that's definitely a viable approach too.
Was wondering.
Okay. Thanks. Yeah, go ahead.
So do you use Feast for storing embeddings? If yes, how will you rate the ability to store embeddings in Feast and whether Feast is a good option to store and look up embeddings for inference?
Yeah, we don't have today a use case doing embedding with Feast. So today it's a no, like we don't do it. I think ideally everything is in Feast. One of the use case I have in mind, they also rely on images, and those to store like embeddings and images to store can take a lot of space in the feature store. And one of the main issue you could have is like maybe scalability of the feature store, like because your data set or your data is going to be way too big to be really well optimized. And maybe in that case, it makes more sense to not use the feature store. Like my point is today, we don't use Feast with embeddings. I don't know if we're going to do it in the near future or not. So yeah, so I don't have a good answer on that. I think if you're curious about that, you should ask any Feast maintainer or ask in the Feast Slack channel to get good examples of people doing that, and you might have some people doing it.
Matt, I also have one question. I think it was regarding the slide 19, where you showed on your mono-repo the feature services and like features. I was wondering what kind of how do you, regarding that repo, how do you persist data if you use like features for that and like feature engineering? If you could give the feature services is like a feature engineering code and then you persist tables? How do you do it? And also, how do you know, like, for example, the more the feature engineering you apply and store those features, the less likely it is for a data scientist to use it, in terms of you may have like feature engineered it too much? How do you tackle these sort of issues?
Yeah, so that's a really good question. I think one thing that we try to explain to our users on how we will build the feature store, or the scope of the project of the feature store at Shopify, is that feature engineering is outside of the feature store. That might sound a bit silly, but it's kind of like we have like 2 tools to do batch transformations at Shopify, one using DBT, one using Apache Spark. And therefore you do feature engineering with those tools. You make data available in like offline store, online store. We help them to standardize how they do feature engineering. So for example, we created like a couple of what we call in-house like loaders, like BigQuery loader, to make sure that the data is loaded to BigQuery in a certain way or in an optimized way. So we help them in loading the data at the right place in the right format. But that remains out of scope of the feature store itself, kind of. It's like all your batch and streaming tools are used for creating like features to do feature engineering. Then you help them to go to the feature store, like the offline, the online store. Mm-hmm. In the feature store really project, you tell where's data live, okay? Because this is kind of plug and play. It's not the feature store that stores data, so its naming can be confusing. And because you just reference what data is, then the SDK of the feature store is just going to do the glue and the magic of like SQL query or these kind of things to fetch the data for you. So yeah, TLDR, feature engineering, is kind of like out of scope of our team, and we try to help them without like doing it for them.
Got it. Great. Thank you. Folks, does anyone have more questions?
So yeah, so the internal business service itself. Oh yeah, so. Yeah, I mean, feel free to ping me on the MLOps community, or I don't know if there's a good channel, Andre, for that, but
sure. I think there's a.
Otherwise, Matt Delac over there. Maybe it can be in an open public channel for more people to jump in.
Yeah, actually, you are giving a good idea. Maybe we should open like a channel for feature stores. That would be nice. Yeah. For example, I'll talk to Demetrius about that. Matt, thank you so much for the presentation. It was awesome. Yeah, for sure.
Thanks you.
Mike, go ahead, man, please.
Sure. So I'm going to go without any slides. So it's just me talking. And try to keep it a bit lightweight. So what I'm going to go over is a system called Kaleidoscope, which is kind of something we use internally, which has one face-off is a feature store. And kind of like to explain what that is, I'll kind of go over the history, say where we are now, and then can talk about some future stuff. So originally it came from a kind of project inside Skyscanner called Machine Relevance. So about 4 years ago, we kind of identified we'd had a few kind of attempts to kind of roll out machine learning in different bits and pockets of the company, but hadn't really kind of scaled out. And so partly to take advantage of the opportunity, there's a whole bunch of people that effectively just put together and said, okay, let's focus on ranking problems. Let's try and work out what all the problems are. And that included kind of not just technical problems, but organizational things of how are you recording the right data and that kind of thing. So that's where Kaleidoscope came from, but it didn't exist at the start. And so the machine relevance effort kind of moved forward. We got to the point where we'd had a few successes as a big group, and we were starting to kind of effectively decompose into smaller teams and start kind of like point a bit at the architecture and say, okay, that is the thing, kind of thing. So it started to become obvious we needed something like a feature store, and we kind of started implementing that. At the time, 4 years ago, there was things like Qflow was around, and there was some feature store-ish stuff there, but it was either kind of basically wasn't robust or kind of like mature enough for what we wanted. So the very first version of Kaleidoscope, before it even had a name, was effectively like a bunch of tables in a database in AWS. But that matured over time to later on do things like storing in DynamoDB and what it is now, that kind of thing. But one of the things that happened, like partway through, maybe about halfway-ish through that 4-year story, there was another side of the company that is what we typically refer to as the lifecycle teams, basically using marketing tools to target people when they're at particular points in their purchase or kind of their kind of life cycle of getting a flight, that kind of thing. And we basically ended up with a hole in our system where we'd gone from one vendor, going to another, we didn't have any data there, and it was kind of a bit of a pivot where it's like, all right, wait a minute, we've got this thing that's being used for machine learning that's very similar data, very similar patterns we need. Can we repurpose that to also publish to these third-party marketing systems? So that's where effectively the second of the two main customers of Kaleidoscope came from, was basically marketers. And that kind of led to us to add capabilities that's more around syncing with external systems rather than what you typically find in a feature store. So that's kind of like a very, very pot history. One of the things that happened on the way is that it got big enough, got a name. It's also got a logo, which is on the laptop, which was actually done by Andrew, who's on the call. So it became a bit more of a brand, a bit more of a kind of like thing, and it kind of became something that lived separately from a machine learning stack. So it's still heavily used as part of that stack, but it's got lots of different users, but the two big main users are marketing and machine learning. And with a particular self-service focus, it was quite interesting listening to some of the discussions about repos, because we've adopted more of an SDK approach where if you take a data frame in a notebook and you publish that to Kaleidoscope, we will automatically create a schema, we will automatically allow it to be published kind of thing. So we've gone very much towards the how do you make it as easy as possible for someone to basically go from having an idea, getting in a data frame and getting it out into production within like an hour or a day kind of thing. The other thing is, I think another theme that came through in Matt's talk was kind of like being a kind of reactor for reusability. So one of the things that you find is that there's a nice kind of flywheel effect where if someone in marketing has an idea, goes talk to a data scientist, they get them to produce what we call an attribute, which is our equivalent of features, get that into Kaleidoscope. 2 months later, someone says, oh, wait a minute, we could do that as well. And then that gets used in machine learning, and vice versa. We've had that happen recently with like some attributes to do with themes of destinations, where originally it was created to support a destination recommendation model, and now we're using it for targeting in our marketing system kind of thing. So it's a deliberate reactor for that sort of stuff. And also, from a technical point of view, there's quite a lot of cross-cutting concerns. So things like GDPR and where Kaleidoscope sits in the company is kind of on the internal boundary between internal systems and kind of external usage. And that's where we apply a lot of our GDPR constraints. Those same constraints apply whether you're using it for machine learning or marketing. Like there's different consents that apply, but the logic is very similar. So you get a lot of value of having a single system that does it. And one of the things that it doesn't support right now, because like so from a real-time point of view, we very deliberately made a compromise at the start that we would go for very slow-moving data, but large amount of data. So we typically only update data once a day when it comes to like publishing stuff. But obviously that's not enough. And there's like needs coming in from both machine learning and from marketing of we would like more up-to-date data. So again, there's like an advantage to having one system which is used in multiple places for solving very similar problems. So that's kind of where we are now and where it's going in the future. So the world has changed outside of us, and so there's plenty of things that are very mature. Feast is one of them. So one of the things that we're considering is effectively doing a bit of consolidation. And one of the things I'm quite a fan of is like worldly mapping. So it's like talks about commoditization, that kind of thing. So one of the ways you could see Kaleidoscope in the future is a bit more of a brand, in the sense that a lot of the stuff that we do in Kaleidoscope is about helping internal customers. That wouldn't change if we took the internals and made it be implemented on Feast. So like there's a useful separation between what's the documentation, what's the kind of experience you give to internal customers versus what are you using it right now for supporting them, like technically kind of thing. And another thing is like there's some stuff that Kaleidoscope is doing where it's kind of becoming a bit of a mini data warehouse when it really shouldn't be. So we kind of need to go back and reintegrate some with some other internal systems to take some of the features out of Kaleidoscope and back into it. But the main thing, and what I originally said to Andre was that the interesting thing about Kaleidoscope is that the cross-cutting concerns aspect. So I don't think it's necessarily the case that every company should expect to have their feature store be used for multiple different things. But there is an opportunity there where I think if you looked at your use cases and talk to your marketers or other similar groups, there's going to be very similar needs and you can maybe dedupe your work. Okay, I'll stop there. That was a bit of a kind of brain dump. I could quite easily talk for hours about Kaleidoscope, as I'm sure Andrew knows. But I'll stop there for questions.
Thank you so much, Mike. Folks, does anyone want to start? Well, I can kick this one off. Mike, when like a data scientist updates one feature, that, for example, imagine that also a marketer also uses that feature from the feature store. How do you communicate? How do you like warn that a feature has been changed and a new version of it has been updated?
So one of the things that we do is we will do version checks. So one of the things that I didn't mention is that we very explicitly built it for evolution. So Kaleidoscope doesn't have a strong opinion about, say, keeping two attributes in sync. So what that means is that you can have effectively two versions of your attribute live at the same time. And what we typically do is we don't automatically communicate kind of like there's been a new version. We just make it possible for data scientists to have a conversation with their downstream customers, mediated by Kaleidoscope, to have two versions that go at the same time. But one of the things that we do enforce to try and keep things kind of correct is that we will spot breaking changes. And basically, if someone tries to publish, like we are lax in some areas deliberately. So, for example, if someone can extend the definition of an attribute to add an extra component to the attribute, because like our attributes are kind of more like feature sets than kind of individual features. So we have kind of attributes and then components. So we'll allow someone to add stuff to an attribute. But if they make a breaking change, we will like say if they published it by the SDK, the data frame, we would just say, nope, sorry, you can't do that. You'll have to either create a new version or you'll have to not do what you're wanting to do, kind of thing. So to go back to your question, we don't explicitly kind of message anyone. That's one of the things that we have enough metadata that we could do that. This has not been at the top of our feature list to do, kind of thing. But so it's more that we try to kind of put in the support for evolvability of attributes, and then kind of like step back and allow the data scientists to talk to the marketers, and Kaleidoscope's more kind of like sitting in the background helping, as opposed to kind of like telling people what to do.
Got it. Okay. And by creating those levels of, if I understood right, by creating those levels of like by extending, you keep like maybe you apply some feature engineering, but you also have the previous step, so that increases really the likelihood and the probability that you end up like having a lot of features that everyone can use, right? It never reaches a point where you cannot go back to the feature engineering that you applied.
So I think there's a tricky thing between kind of I think there's two things going on there, because like there's some types of changes that are actually changing the shape of the data, which are more schema changes, and there's other ones where you're just improving stuff over time, and you're not creating a new shape, but you're just creating a new instance of that for a new day, kind of thing. And we tend not to get in the way or kind of particularly try and monitor that latter one. Yeah, so you can see your question again, because I think I've lost the thread.
So basically, you keep extending those instances to keep having more and more. You still retain the information from like an instance data.
Because behind the scenes it's backwards compatible in the sense that when you read the data, even if you've added a new schema, it's effectively a null. As long as you can have nullability of anything, then any old components of that thing will look empty, kind of thing. But there's a kind of interesting social aspect here of there's always a trade-off between the flexibility, the freedom of any particular user, whether it's a marketer or a kind of data scientist. One of the things that we do is that although we allow people to automatically publish to the SDK and it automatically creates a schema, that still goes and creates a PR in a repo, which we then have to approve before anyone can use it. So it gives a little bit of an opportunity for us to go, oh, wait a minute, that thing you're proposing to create looks pretty damn similar to the other thing that already exists. Do you want to be able to talk to them first and before we approve it? That kind of thing. And so there's always a bit of a deliberate tension between trying to enable people so that they can get out of the way and get on with it, but then also not kind of, the way I tend to think of it is like, if everyone does about an extra 10% of work, then the whole company benefits and you get a better net improvement rather than trying to make any one person's life the easiest kind of thing.
Oh, okay, I have a question. So when we are doing a development, we might have different kind of transformations. We would have tested it out, right? And for a different client perspective, maybe one set of transformations we would need for one client set of data or something like that. How we can support through Feast? Is it only with the version changes, or like with versioning we'll be able to manage, or?
So I think if you're talking specifically about Feast, then that's probably more of a question for Matt, I think.
Okay. No, but Matt clearly mentioned that feature engineering part they have not used much in the Shopify stuff, right? Like Matt, or want to take that question?
I can maybe answer a version of the question based on stuff I've seen for Kaleidoscope, and then maybe Matt, you could have a go at it with Feast. So like one of the things about the kind of having attributes with components is that one of the things we find is that a producer might produce an attribute with lots of different components. So one example is we have this thing called origin preferences, which is basically a guess at your home airport. Now, the original users or usage of that had a fairly complex kind of breakdown of scoring for each destination, whereas some consumers only wanted like the top scored one. And so we asked the producer to go, or they asked the producer to go back and add a summary component. And then when that's being used for, say, marketing use cases, they can actually subset that and only publish that particular component that they care about, kind of thing. So it's a roundabout way to say we've allowed more flexibility by allowing subsetting of features or feature sets, as opposed to trying to support a new feature for every use case, kind of thing. Matt, do you want to go at the Feast side of that?
Yeah, I'm not sure I completely get your question, Divya, but maybe yeah, maybe we can take it offline, I think, on that side. So Mike, you can, okay. I had a question for you, by the way. So I think if I understood properly, this is implemented in Go, right?
No. This is all implemented in a mix of Java and Python.
Oh, okay, Java and Python. Okay.
So the reason I say a mix is because, well, I mean, it's basically all Java, but like a lot of the interfaces are Python. So what we actually do behind the scenes is that because a lot of our service stacks, we kind of have one face, the live face of feature store is effectively a kind of protobuf service, vending service. So and a lot of the kind of live stack that we have is Java based for performance reasons. But the way the data is published is typically from a notebook or from some sort of alchemy job running Python. So behind the scenes, we'll have some stuff that converts the schema from Spark effectively to protobuf. All of that is in Java. So there's bits of the surface which are different languages. So we kind of got Python, Java, and Node kind of SDKs, but the core of it is pretty much all Java.
Okay, sounds good.
I also have a question, maybe for both of you guys, if you want to have a take on this. Like I still have, it's not still clear to me what regarding performance-wise, how do you decide what sticks to Spark or Pandas? Pandas probably not. Maybe let's take Spark. And what stays in SQL? How do you like manage those two?
So I mean, I think that maybe goes back to something that Matt touched on earlier on, and we chat about internally is so as with what Matt was talking about, all of the feature generation happens outside of Kaleidoscope. So Kaleidoscope is the place that it gets saved and then can be reloaded kind of again. And there's lots of different trade-offs around. So we were just talking internally yesterday about how the costs of saving stuff and converting it through pandas, and it's not got a perfect kind of story for data scientists right now for both online and online. It's a kind of a bit it could definitely be improved, and there's some bottlenecks there that are to do with pandas and stuff like that. But the tricky thing tends to be that, for example, Spark is very well designed for executing at scale in batch modes, but there's not a really good equivalent for online. There's kind of Spark streaming, but that's not as mature as the rest of Spark and that sort of stuff. So, but it's definitely the case that for us internally, we could have a way better story of that unified kind of experience for data scientists, and that's actually legitimately tricky. And that's actually why I'm interested in the future, maybe going for a more commodity thing, because that's not a new problem. Everyone has that problem, so it can be shared and kind of solved jointly.
Yeah, I have some thoughts also on that. It's like, I think what if you look at like ML pipelines, what you try to have is different stages that are kind of atomic, I would say. So it's like you want to have a stage that is retrieve features, materialize that, even though sometimes it's not the most efficient way, but materialize that so that then you have your training step or even pre-processing step training and so forth and so on. So it's kind of like you can use any feature store that use any backend store to retrieve the features, put that in your data warehouse. For us, it's, for example, GCS with Parquet format, and then have your training step reading data and just like do it at scale, but with PySpark, or we use Array. That is a way to distribute Python code. So, you know, like you just don't have to use the same tools from all your ML pipeline, right? So I think for us, it's also like this concern is more like what needs to run at scale and what does not need to run at scale, and how you just differentiate the different steps of your ML pipelines.
Yeah, and just one thing to add to that is the tricky thing of combining older data with newer data. So like you might have the situation where, so like it's really typical in kind of our domain where people don't come and visit Skyscanner every single day because you're not necessarily booking a holiday every single day. But you might still have quite a lot of historically derived attributes for the person. When they come and visit now, do you try and represent that as a separate attribute? So you have kind of like the same thing. One of them is like a historical snapshot and one's a kind of newer version of it, or do you try and kind of push some of that merging into the feature store? And I think that one of the things a bit tricky about the feature store boundary is how clever do you want to make it versus how much do you want to layer on top of it, kind of thing. And that's one of those tricky things that keep on coming back to is of combining a large amount of older data with a small amount of newly updating data and trying to make the easiest experience for a user of the feature store. Yeah.
Guys, does anyone have more questions for our guests?
Thanks for the invitation, Andres. That was fun. That was very cool.
Yeah, thank you so much for both of you guys to come and join us.
Thanks for organizing.
Yeah, I think you can wrap this one off then.
Yeah,
cool.
And feel free to share. Yeah, and feel free to share this Slack channel wherever where people can ask.
Yeah, I'll talk with Demetrius for that. I have this recording will be then uploaded to YouTube, and I'll share with you guys the link as well for sure.
Yeah, and as with Matt, feel free to ask me any questions on the MLOps Slack.
Thank you so much.
Yeah, with pleasure. Well, thanks everyone. Have a good day.